Hello and welcome to the C++11 Beginner Tutorials by Gamer2Creator. I'm Chris. Okay, the next lesson we are going to talk about dynamic memory. I intentionally left it out of the pointers video because I wanted you to know that pointers aren't just for dynamic memory, which is something that people can get caught in thinking at the start. It's very easy because that's what most of the examples will show you doing, is just using references to pass by references and pointers to handle dynamic memory on the heap, but that's not really the only use for them, so I wanted to separate that out. Now, dynamic memory. What is dynamic memory? Well, so far I don't believe we've used dynamic memory yet in these videos. Dynamic memory involves the use of new and delete. These are two keywords. They'll show up blue in the editor because keywords are made blue. Now, new and delete involve pointers, obviously. New will return a pointer to an object created on the heap. So we're going to have a foo pointer to a foo equals new foo. And we need to pass it 800 and 600. So we're going to get rid of that function. Actually, we'll keep it for now. Might need it later. Now, what have we done here? We've done almost the same thing as this, in that we created a foo object here and we created a foo object here. As you can see, that's nearly identical, only we don't have a variable name right there. The reason for that is we're constructing an object on the heap. New tells the language that you want this object put on the heap and that you need a pointer to it, because pointers are how you reference an object. That's how you point to an object on the heap. And then we copy the temporary value that was created here, which is a pointer to a foo, and we've copied that right here. In this one, we actually created one on the heap which lives within the main function. Here, only the pointer variable actually lives in the main function. This lives somewhere in memory, God knows where, in a location often called the heap, which is really just a whole bunch of memory that you can use, which is quite scattered in most cases. Alright, so obviously we could do a foo im height equals some number, and that one is modifying the variable foo that was not created on the heap, or we can modify the object that we're pointing to with our pfoo here. Now, all's well and good. We can modify ours just like this, which is almost exactly the same as regular variables. Only use that syntax, the pointer syntax, to dereference and access your object that you're pointing to. But you have to tell the program when you're done with that memory. You have to tell the language in your computer, okay, I'm done with this object on the heap. You can free that memory up. And you do that with the delete keyword. You say delete pfoo. And then often, you should probably get in the habit of doing pfoo equals null pointer, which is the same as pfoo equals 0. The reason for this is that 0, the address of 0, the number 0, is an invalid address. I mean, it's not a usable address. It's called a null address. And you can use that for checking to make sure your pointer actually points to a valid address, because you can set pointers to null and everyone knows that you should check a pointer for being null before you access that pointer. And I'll show you what I mean up here. So we've created the new pointer and we deleted it and we set it to null. That's great. And you have to remember to do this. You have to do it manually. Now what I want to do is call our some foo func. Pass it our pointer to a foo. First thing we should do in this function is go if p foo equals null pointer, and you could also say equals 0, return. Do nothing. Oops. So if we pass in a pointer that has a value of 0, meaning it points to nothing, then it will check that and do nothing in this function. It'll just return. Nothing will happen. But we're going to have to return something 0.0f, I guess, because we have a float there. We're returning a float. And this is actually a pretty good example of a reason that you would use a reference. Why don't I go ahead and do that? Okay. So I know this is getting a little complex. I understand. That's C++ for you. It is a complex language, mainly due to pointers. And you need to get used to having variables that aren't the variable you're modifying, but indirectly modifying another variable through a variable, such as a pointer and a reference. Okay, so we're going to come in here, we're going to call this function aspect. Okay, that doesn't need to be redeclared. Now as you can see, we've got our foo, we have our foo up here, we've changed height to 100. We're passing in our pointer and a aspect float variable, but it's being passed by reference. So inside this function, we're changing our aspect variable from here, and we're changing our foo from here. So let's step in. First thing I'm going to do is I'm going to make sure I've got a valid memory address. Okay, I do. Cool. So we're going to do the check, make sure the height is more than or equal to 0. Yes, we're good. Alright, let's calculate the aspect ratio. As you can see, we've got 8.000. That's because our width is 100 and our height is 100. And we should expect this to also be 8 because we passed it by reference. And we come out here, yes, it is 8. Okay. So now let's say we're going to change this to -10. Now because the object that foo points to, our pointer here, pointer to a p foo, because this object is being passed by pointer up here, and its m height value is -10, this object should get its height set to 0 within this function. And aspect should not be changed while we're in here. So let's go ahead and load that up. Step into. Okay, so the memory address is valid. We do our check here for less than or equal to 0. It fires. Now we're going to set m height to 0. And you should expect that this pointer, this will change to 0. This pointer that points to this object, its height will change to 0 when we step over. And as you can see, it has. So I tried to get a fairly complex example that wasn't too bad as a way to teach you how pointers work. You're going to get lots of practice using pointers. But C++11 actually has some classes and functionality that should make this a lot easier. So you don't always have to remember to call delete yourself, though it is being called for you. I hope to see you in the next video.